According to the National Electrical Code, it is permissible to run multiple current-carrying conductors of differing voltage systems within the same raceway. However, this allowance comes with specific stipulations. Firstly, the raceway must be metallic. Secondly, the raceway's fill capacity must adhere to the code requirements. This means that the combined cross-sectional area of all conductors within the raceway should not exceed the maximum allowable fill percentage as specified in the NEC. Additionally, differing voltage systems are permitted to exist within the same junction box or disconnect enclosure. A crucial provision arises when these different systems share a common neutral conductor. In such instances, the shared neutral conductor must be insulated. This insulation is vital for preventing unintended voltage imbalances and ensuring safety. For comprehensive guidance on these regulations, consult the relevant sections of the National Electrical Code. Specifically, refer to Section 300.3c, which addresses the general requirements for conductors of different systems. Furthermore, Section 300.5 provides additional details and considerations for underground installations. It's important to consult the latest version of the NEC for the most up-to-date and accurate information, as codes can change over time. Electrical work should only be performed by qualified individuals who are familiar with the applicable codes and safety procedures. Raceway fill calculations are essential to ensure the safe operation of electrical systems. Overfilled raceways can lead to overheating of conductors, which can damage insulation and potentially cause fires. The NEC provides tables that specify the maximum number of conductors allowed in a given raceway size based on conductor size, type, and insulation. These tables take into account the heat generated by the conductors and the ability of the raceway to dissipate that heat. Factors such as ambient temperature and the presence of other heat sources can also affect the allowable raceway fill. When running conductors of different sizes in the same raceway, it's necessary to calculate the overall cross-sectional area of the conductors to ensure that the raceway fill is within the limits specified in the NEC. There are specific formulas and tables available for making these calculations. In situations where it is difficult to determine the exact raceway fill due to the complexity of the installation, it may be necessary to use a larger raceway size to ensure compliance with the NEC. Proper conductor sizing is crucial for the safe and efficient operation of electrical systems. Undersized conductors can overheat, leading to voltage drop and potential equipment damage. The NEC provides tables that specify the minimum conductor size required for a given load, based on factors such as ampacity, ambient temperature, and the type of insulation. The ampacity of a conductor is the maximum amount of current that it can safely carry without exceeding its temperature rating. The NEC specifies ampacity ratings for various types of conductors based on their insulation type and installation conditions. When selecting conductors, it's important to consider the voltage drop that will occur over the length of the circuit. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The NEC recommends limiting voltage drop to a certain percentage of the supply voltage. There are formulas and tables available for calculating voltage drop in electrical circuits. Proper grounding is essential for electrical safety. Grounding provides a low impedance path for fault current to return to the source, which helps to trip over current protective devices and prevent electrical shock. The NEC specifies grounding requirements for various types of electrical systems and equipment. Grounding electrodes, such as ground rods and ground plates, are used to connect the electrical system to the earth. The size and type of grounding electrode required depends on the size of the electrical system and the soil conditions. Grounding conductors are used to connect equipment and enclosures to the grounding electrode. The size of the grounding conductor required depends on the size of the circuit and the type of equipment being grounded. Ground fault circuit interrupters or GFCIs are devices that are designed to protect people from electrical shock. GFCIs monitor the current flowing in the hot and neutral conductors of a circuit. If there is a difference in current between the hot and neutral conductors, it indicates that current is leaking to ground. When a GFCI detects a ground fault, it quickly trips the circuit, interrupting the flow of electricity and preventing electrical shock. GFCIs are required in many locations, such as bathrooms, kitchens, and outdoor areas where there is a high risk of electrical shock. Arc fault circuit interrupters or RFCs are devices that are designed to protect against fires caused by arc faults. Arc faults are dangerous electrical conditions that can occur when damaged or deteriorated wiring creates an unintended electrical discharge. RFCs monitor the electrical circuit for the characteristics of an arc fault. When an RFC detects an arc fault, it quickly trips the circuit, interrupting the flow of electricity and preventing a fire. RFCs are required in many locations, such as bedrooms and living rooms, where there is a high risk of arc faults. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. Overloads occur when too much current flows through a circuit, causing the conductors to overheat. Short circuits occur when there is a direct connection between two conductors of different polarity, resulting in a very high current flow. Circuit breakers are devices that automatically trip and interrupt the flow of electricity when an overload or short circuit occurs. Fuses are devices that contain a fusible link that melts and interrupts the flow of electricity when an overload or short circuit occurs. The size of the circuit breaker or fuse required depends on the ampacity of the circuit and the type of load being served. Proper wiring methods are essential for the safe and reliable operation of electrical systems. The NEC specifies wiring methods for various types of installations, including residential, commercial, and industrial. Wiring methods include the type of wiring, such as non-metallic sheathed cable, armored cable, or conduit, and the way in which the wiring is installed and supported. All electrical work should be performed in accordance with the NEC and other applicable codes and standards. It is important to obtain the necessary permits and inspections before starting any electrical work. Electrical work should only be performed by qualified individuals who are familiar with the applicable codes and safety procedures. When working on electrical systems, it is important to take all necessary safety precautions, such as wearing appropriate personal protective equipment and energizing circuits before working on them. Lockout-tagout procedures should be followed to ensure that circuits are not accidentally energized while they are being worked on. Regular maintenance and inspection of electrical systems can help to prevent problems and ensure the safe and reliable operation of the systems. This includes checking for loose connections, damaged wiring, and worn components. Any problems that are found should be corrected promptly. Electrical safety is everyone's responsibility. By following safe practices and being aware of the hazards of electricity, you can help to prevent accidents and injuries. Always call a qualified electrician if you have any questions or concerns about electrical safety. Additional considerations include the type of insulation used on the conductors. The NEC specifies the types of insulation that are permitted for different applications. The insulation must be suitable for the voltage and temperature of the circuit, as well as the environmental conditions in which it is installed. The color coding of conductors is also important. The NEC specifies the color coding for various types of conductors, such as hot, neutral, and ground. Proper color coding helps to ensure that electrical circuits are wired correctly and safely. The use of electrical tape is also important. Electrical tape is used to insulate and protect electrical connections. The NEC specifies the type of electrical tape that must be used for different applications. The tape must be suitable for the voltage and temperature of the circuit, as well as the environmental conditions in which it is installed. The proper installation of electrical boxes is also important. Electrical boxes are used to enclose and protect electrical connections. The NEC specifies the type of electrical box that must be used for different applications. The box must be suitable for the voltage and current of the circuit, as well as the environmental conditions in which it is installed. The grounding of electrical boxes is also important. Metal electrical boxes must be grounded to provide a path for fault current to return to the source. The NEC specifies the methods for grounding electrical boxes. The use of cable ties is also important. Cable ties are used to secure and organize electrical cables. The NEC specifies the type of cable tie that must be used for different applications. The cable tie must be suitable for the environmental conditions in which it is installed. The proper support of electrical cables is also important. The electrical cables must be supported in accordance with the NEC. The supports must be spaced at intervals that prevent the cables from sagging or becoming damaged. The protection of electrical cables from physical damage is also important. Electrical cables must be protected from physical damage by using conduit, raceway, or other approved means. The identification of electrical circuits is also important. Each electrical circuit should be clearly identified with a label or tag. The label or tag should indicate the purpose of the circuit and the location of the overcurrent protective device. The documentation of electrical systems is also important. Accurate documentation of electrical systems is essential for maintenance and troubleshooting. The documentation should include wiring diagrams, panel schedules, and other relevant information. It's also important to ensure that all electrical equipment is properly listed and labeled. Listing and labeling indicates that the equipment has been tested and certified by a recognized testing laboratory such as Underwriters Laboratories UL. Listed and labeled equipment meets the safety standards required by the NEC. Before working on any electrical equipment, it's important to read and understand the manufacturer's instructions. The manufacturer's instructions provide important information about the proper installation, operation, and maintenance of the equipment. When working on electrical equipment, it's important to use the proper tools. Using the wrong tools can damage the equipment or create a safety hazard. Always use insulated tools when working on energized circuits. When making electrical connections, it's important to use the proper connectors. The connectors must be suitable for the type of conductor being used and the voltage and current of the circuit. Always make sure that the connections are tight and secure. When splicing conductors, it's important to use the proper splicing methods. The splices must be mechanically strong and electrically sound. Always insulate the splices with electrical tape or other approved means. When terminating conductors at equipment terminals, it's important to follow the manufacturer's instructions. The terminals must be properly sized for the conductor being used. Always make sure that the connections are tight and secure. When installing electrical equipment, it's important to maintain proper clearances. The NEC specifies the minimum clearances that must be maintained around electrical equipment. These clearances are necessary to allow for access for maintenance and to prevent overheating. When working on electrical systems in hazardous locations, it's important to follow the special requirements for those locations. Hazardous locations are areas where there is a risk of fire or explosion due to the presence of flammable gases, vapors, or dusts. The NEC specifies the types of equipment and wiring methods that are permitted in hazardous locations. When working on electrical systems in wet locations, it's important to use waterproof equipment and wiring methods. Wet locations are areas where there is exposure to water, such as bathrooms, kitchens, and outdoor areas. The NEC specifies the types of equipment and wiring methods that are permitted in wet locations. When working on electrical systems in corrosive environments, it's important to use corrosion-resistant equipment and wiring methods. Corrosive environments are areas where there is exposure to chemicals or other substances that can corrode electrical equipment. The NEC specifies the types of equipment and wiring methods that are permitted in corrosive environments. When working on electrical systems in healthcare facilities, it's important to follow the special requirements for those facilities. Healthcare facilities have special electrical requirements to ensure the safety of patients and staff. The NEC specifies the types of equipment and wiring methods that are permitted in healthcare facilities. When working on electrical systems in educational facilities, it's important to follow the special requirements for those facilities. Educational facilities have special electrical requirements to ensure the safety of students and staff. The NEC specifies the types of equipment and wiring methods that are permitted in educational facilities. When working on electrical systems in detention facilities, it's important to follow the special requirements for those facilities. Detention facilities have special electrical requirements to ensure the safety of inmates and staff. The NEC specifies the types of equipment and wiring methods that are permitted in detention facilities. Remember to always prioritize safety and consult the latest edition of the National Electrical Code for the most accurate and up-to-date information.